Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Dear students, today our theorem is prove that every fully invariant subgroup of a group G is normal in G. Proof. We have proved that every fully invariant subgroup of a group G is characteristic in G. We have proved, and we also proved that every characteristic subgroup of G is normal in G. Every fully invariant subgroup is characteristic, and every characteristic is normal in G. Consequently, every fully invariant subgroup of G is normal in G. We will prove these two statements in the given theorem. Now, next theorem. Let G be an abelian group, and let H is equal to x belong to G such that x power n is equal to 1. It means that H contains those elements of G for which the power of x power n is equal to 1. Prove that H is fully invariant subgroup of G. Proof. First, we show that H is a subgroup of G. Clearly, H is non-empty because 1 belong to H, or 1 power n is equal to 1 and 1 belong to H. Also, if we take two elements xy belong to H, then by the definition of H, x power n is equal to 1 and y power n is equal to 1. Now, for the subgroup, we will show that xy inverse whole power n is equal to 1. Now, xy whole power n is equal to x power n, y power n, y inverse whole power n. As G is abelian, this implies that AB whole power n is equal to A power n, B power n. X power n, y power n whole power inverse. Now y power n is equal to 1 and x power n is equal to 1. 1 power minus 1, 1, 1 dot 1 is 1. This implies that xy inverse belong to H, showing that H is a subgroup of G. Next, we show that H is fully invariant in G. That is, H under alpha is a subset of H. For this, we take an element x belong to H. Then by definition of H, we have taken H, if x belong to H, then x power n must be equal to 1. Now for any endomorphism alpha of G, we have x power n under alpha, x power n is equal to 1, 1 alpha is equal to 1. We can also write x alpha whole power n because alpha is homo. This implies that x under alpha belong to H because x alpha whole power n is equal to 1. And we know that H contains those elements whose power n is equal to 1. That is, x belong to H implies that x alpha belong to H. This holds for any x belong to H, and it follows that H under alpha is a subset of H, showing that H is a fully invariant subgroup of G. Now, we have next theorem. Prove that all the subgroup of a cyclic group are fully invariant subgroup of that cyclic group. Proof. Let G be a cyclic group. If it is cyclic group, then it must be generated by an element. Let's suppose A belong to G in element, and let H be any subgroup of G, then obviously H is also cyclic. If H is cyclic, then it must be generated by an element, and that H is generated by A power k, where k belong to Z. Let alpha from G to G be an endomorphism of G. Now, to prove that H is fully invariant, we shall show that H under alpha is a subset of H. For this, we take an element y belong to H alpha. Then by definition of H alpha, there exists some x belong to H such that x alpha is equal to y, or y is equal to x under alpha. Now x belong to H, and we know that H is generated by a power k. This bracket represents, that is, it is generated by a power k. This implies that then x will be equal to a power k whole power s for some s belong to z, and double power will be written as x is equal to a power ks. Now y is equal to k x alpha, and x is equal to a power ks under alpha, and we can also write a bracket alpha whole power ks because alpha is homo. Now a under alpha belong to G, and we know that G is generated by A. So A alpha is equal to A power T for some T belong to Z. Y is equal to A bracket alpha whole bracket Ks, and we know that A alpha is equal to A power T whole power Ks is equal to A power Ks bracket T. Ks will be under and T will be whole power, and this is equal to x. A power ks is equal to x whole power t belong to H. As x belong to H, that is y belong to H. So we have shown that if y belong to H alpha, then y belong to H, and hence H under alpha is a subset of H. Since this holds for every endomorphism alpha from G to G, now hence H is fully invariant in G that is required.